Welcome everybody to our third day of the COSI Science Festival here in Columbus, Ohio, but now broadcast across the world. This is the second year we did this festival. We really wanted to create an incredible science literacy and science engagement experience for the city of Columbus, the county of Franklin, and the entire state of Ohio. And in fact, last year, the governor called it the largest science event in the history of this great state. Our lead partner last year, without question, was NASA. They were incredible. We had all 10 research sites here in Central Ohio, and we couldn't be more thrilled to have this amazing second-year partnership bringing to you this program today, which I promise will knock your socks off. So this is our Science Festival. We are on day 3. It will finish tomorrow with our big at-home science celebration. So go to cosicifest.org. Pick your poison, enjoy what we got. It's an awesome time. With that, before I introduce our distinguished guests, I want to kick it to video. Is it just or Wow, that was fantastic. Those images were really, really cool. And those of you who couldn't hear it, that's because we're gonna have our special guest do it from scratch right with us right now. With that, I'm so excited to introduce none other than the NASA administrator, Jim Bridenstine. Now, before you say a word, just so everybody in the audience knows, when we say NASA administrator, we're talking about the bad boy CEO, head of all of NASA. He is the man who is leading NASA to its next great phase. And with that, I'd like to introduce Administrator Bridenstine. Welcome to the program. Thanks so much for spending some time with us at the COSI Science Festival.
Well, Dr. Bertley, it's always great to be with you. I'm a big fan of COSI, and I understand I owe you and your whole team a big congratulations. USA Today announced that COSI was the #1 science center in the nation. So congratulations to you and the team. Certainly I saw that with my own eyes when I visited last year, and I look forward to coming back again soon once we get past the coronavirus pandemic here. But I can't wait to get back.
Well, you got it. As you know, you have an open invitation, and yeah, it was an honor to be voted by peers across the country and the average Joes and Janes of this great nation to say we're the #1 science center in the nation. So thank you for recognizing that. Well, that's been great. So I got to ask you, because I know we don't have a ton of time, tell us about Artemis. What's the Artemis Project?
So what we're doing as an agency is we're going back to the moon. I don't like to say we're going back to the moon. I like to say we're going forward to the moon, because this time when we go, we're actually going to stay. One of the things that we love about Apollo is that we got to the moon. The problem is it eventually ended. And under the Artemis program, we're going to the moon sustainably. We're going with international partners, which, by the way, we didn't have back in the 1960s. We're going with commercial partners, which we also didn't have in the 1960s. We're going to go and we're going to use the resources of the moon, hundreds of millions of tons of water ice on the surface of the moon. Water ice represents life support. It's air to breathe. It's water to drink. And in fact, it's rocket fuel. It's the same rocket fuel, hydrogen. Liquid hydrogen is the rocket fuel that powered the space shuttles, and it's available in hundreds of millions of tons on the surface of the moon. But we're doing this with a purpose. Mars is, or I should say, the moon is the proving ground. Mars is the destination. So we go to the moon to learn how to live and work on another world so that we can go to Mars, which of course is an order of magnitude more difficult, but still accomplishable, and this agency intends to do that. Now, I want to say one last thing here, Frederic, on when we talk about Artemis. You know, if you think about Greek mythology, Apollo had a twin sister. Back in the 60s, we had the Apollo program. Well, Apollo had a twin sister, and her name was Artemis, and she was the goddess of the moon. This time when we go to the moon, unlike the 1960s, we're going to go with all of America. We now have a very diverse, highly qualified astronaut corps that includes women. And so this time when we go to the moon, we're going with not just the next man, but also the first woman. And in fact, we're naming it after Apollo's twin sister, Artemis. So this is something that I think will inspire all of America.
Well, that's really exciting to hear. And as you know, you're talking to the head of COSI. One of my predecessor's predecessor was none other than the NASA astronaut, Kathy Sullivan. So the fact that you are calling it Artemis and sending definitely a woman to the moon is fantastic. Really appreciate that, but it means a lot to us here in Central Ohio. I remember hearing from the time I was a kid when Sputnik was launched, and that catalyzed us to do our race to the moon, and NASA grew into this incredible body. What a lot of people don't understand is all the other trickle-down things, if you will, that come to society, to our great world because of these NASA efforts. Can you share a little bit about how the technology distills to our greater world?
Absolutely. So here I am in the living room of my home in Oklahoma. And I can tell you a lot of people in rural Oklahoma, probably not dissimilar from people in rural Ohio, they get their internet from space. So internet broadband is now available from space. That's a form of space-based communications. But it's also true for DirecTV and Dish Network, XM Radio. We think about GPS and how that has transformed how we navigate. We talk about how we produce food. NASA is using its technologies to increase crop yields while reducing water usage by 25%, and at the same time preserving nitrates in the soil so we don't have to get our water dirty and those kind of things and clean it out later. We're using NASA technology to produce energy more cleanly. We're using NASA technology to predict weather, to understand climate, and certainly for disaster relief. And of course, our technologies are also used for national security. As we develop technologies, they often have other uses. But this is really just the beginning. You know, what I hear about as the NASA administrator, I hear about Tang and I hear about Velcro. And I have to remind people that's so 1960s, right? Think about where we are today. The impact that this little agency, and to be clear, and I know you know this, Frederic, we have less than 1/2 of the federal budget, less than half. And at the same time, we're delivering on all these capabilities that are being commercialized. The key is we want to commercialize these capabilities so that all of humanity can take advantage. And that's what we've been doing. And that's the legacy of NASA. And we're moving forward with that each and every day. But there's so many spin-offs. We produce a book. You're going to like this. And I know you're probably familiar. We have a book. It's about an inch thick. We produce it every year on all of the spin-offs that come from NASA. Things like the camera in your cell phone. I'm on a laptop right now. The camera in this laptop is a NASA technology that got spun out. And it was designed for a robot that we put on Mars. And now it's not only in everybody's computer, but it's also on everybody's cell phone. Nokia was interestingly the first company to license that capability, and it has transformed the world. Yeah. So look, NASA is always developing new capability and technology, and today is no different than it was in the 1960s.
No, I mean, I think that's one of the most powerful messages, and I love how you framed that up, because yes, it's super exciting to go to the moon again. Yes, it's absolutely fantastic to dream and actually activate the reality of getting to Mars. Unfortunately, for a lot of folks who aren't astronauts or aren't NASA employees, they might not necessarily get connected to that. And so the fact that that's just a tip of the spear of what NASA contributes to society for this great country, and in fact for the world, is unbelievable. And as we're a science center and opportunities in STEM careers, and NASA itself, your book and all the other things you do, is a perfect roadmap for any kid, any adult for matter, to think about the amazing occupations you can have. Yeah, we'd all love to be an astronaut, but there are probably 200 to 1,000 types of engineers you could be. So can you talk about NASA and kids and being that hyper catalytic agent to get people to be excited about science?
Absolutely. And Dr. Bertley, now is a time like none other in the history of the world. We have this coronavirus pandemic that has devastated so many people. A lot of people have lost jobs. A lot of people have had loved ones get sick, even lost loved ones. And so the question is, what do you do in this moment to inspire the nation, to inspire the world? We have learned that we can flatten the curve. We have learned that we can actually bend the curve the other way when it comes to the coronavirus pandemic. The question is, now that we have done that, what can we achieve? What is something that will make everybody look up and be inspired and be proud? And in just a few short weeks, on May 27th, we're going to launch American astronauts on American rockets from American soil. That's something we have not done since 2011, the retirement of the space shuttles. And this time, when we do it, we're not doing it with NASA owning and operating all of the hardware. We're turning to our commercial partners, and we're going to say, how does NASA become a customer, one customer of many customers in a robust commercial marketplace in low Earth orbit? And how do we have numerous providers that are competing against each other on cost and innovation, enabling more people than ever before, more companies, more researchers, more institutes, maybe more science centers, Frederic? How do we get more people engaged in the ability to go to space? And that's really what we're working on as an agency. That's what this launch, Commercial Crew, it's a SpaceX Dragon rocket SpaceX Falcon rocket with a Dragon crew capsule. And we're going to the International Space Station here on May 27th. I think it's going to inspire the world. And the goal here is, if you're a young person in this country, and you want to be part of a program like this, there's going to be more opportunity in the future than ever before. And we welcome you to get engaged.
That is, you talked about having a science center on the moon. We will call COSI the Center of Space Initiatives, and you can team up with our team and the other great science centers. We'll definitely have that planted on the moon right next to the Artemis Project.
There you go. And to be clear, we are going to create a base on the moon. We want to go sustainably. And there in Ohio, and I know you know this, Dr. Bertley, you know this, there in Ohio at the Glenn Research Center in Cleveland, amazing work is being done to enable that eventual moon base. So there in Cleveland at the Glenn Research Center, they're advancing what we call solar electric propulsion so that we can have maneuverability with a space station that will be in orbit around the moon. We've never built a space station for human activity in orbit around the moon, but now we're doing it. And because of the Glenn Research Center there in Ohio, it's going to be maneuverable. We're going to be able to get to the North Pole, to the South Pole, to the equatorial regions of the moon. And also they're developing the power systems that are necessary to live and work on the moon for long periods of time, a project called Kilopower. And so Ohio is really at the center of our eventual moon missions.
Sure. I mean, that's fantastic. And, for the listeners out there, this is being brought to you by COSI Science Festival right here in Central Ohio. We have none other than the lead chief CEO administrator, Jim Bridenstine, who just is sharing how deep and profound NASA is. I know a decade ago, folks said NASA was kind of sleeping. You have taken NASA by the horns and taken it to the whole next level. And it's really exciting that it's not just about space travel and exploration, which that is a fundamental key, but it's about transformation of our very planet and assisting our society to be better through their great inventions, discoveries, and technologies. So with that, I thank you. I know we're going to get some questions, so I just want to tee that up. But while we tee up the questions, I do want to ask one more question. What do you do at night?
What do I do at night? Well, I'll tell you, I've been reading a lot. When I'm home, all of NASA, other than a few mission essential functions, we're all working from home right now. Okay. Not unlike a lot of people around the country. So while we've been on this podcast, you've probably heard my dogs bark. You might have heard my children yell at each other a thing or two. These are the days that we live in right now. And so I will tell you that I absolutely love being at home. Rather than traveling the country, which is what I was doing before, I'm doing a lot of phone calls and a lot of teleconferences. But I'm home for dinner every night right now. I get to put my kids to bed every night. These are you're going to make me emotional here, but these are very special moments that we think back, and it's a reminder of really the who we are as people, and that even in the midst of a coronavirus pandemic, good things can happen.
Absolutely, and I wanted to pull that out because clearly you're a rock star, from being a Top Gun pilot to now heading up NASA. I view you as a superhuman. Many people do, which is wonderful. But it's also nice that the audience knows that you are superhuman with regular human characteristics. You have kids, you tuck them in at bed, you have dogs that are barking, and that connection is critical, because when people look at you as a role model, they can see themselves in that role and identify themselves. So thank you for sharing that. Still waiting for questions. So until they come in, I'm going to keep them coming. So there's the moon, there's Mars. What's the 50-year idea you and your NASA colleagues have in your minds for where NASA could go?
So that's an important question, and it's really undetermined at this point. What we need to do is we need to have sustainability on the moon, and we need to use what we learn on the moon to go to Mars. Once we go to Mars, the question is, well, where do we go from there? And I'll tell you, there's enough science to do on the moon and on Mars that it could occupy us for a long time. But I would also say there's a lot of astrophysics that needs to be done. And just since I've been the administrator, we've discovered hundreds, maybe even thousands at this point, of planets around other stars in our own galaxy. So we think about our galaxy. We've got 100 billion stars in the galaxy. And now what we're discovering, and by the way, we've discovered, I think it's something like 9,000 planets around other stars. But since I've been the administrator, we've discovered hundreds of those 9,000. But when we think about that, Think about 100 billion stars in our own galaxy, and each one of those stars has dozens of planets around it. And then when we think about the fact that there's hundreds of billion, there's at least 100 billion galaxies in our universe, each with 100 billion stars, maybe on average. And each one of those stars has planets in these other galaxies. The question is, how much more is there for us to learn? You know, we had a 17-year-old intern at the Goddard Space Flight Center in Maryland, and he was interning last summer. And on his third day at work, he discovered a planet orbiting a binary star system. So think of two stars that are orbiting each other, and then a planet that is orbiting the two stars as they orbit each other. And he made this discovery. It's something like I don't know how many light years away it was, but it was a long way away. And this was a 17-year-old intern. Talk about an amazing moment in time, and those kind of things are happening all. And the question is, Frederic, this is going to blow your mind. We have now found liquid water 12 kilometers under the surface of Mars. What do we know about liquid water on Earth? Wherever it exists, there is life. Yep. Now, is that true on Mars? I don't know, but we should go find out. Yep. We now know that the methane cycles of Mars match the seasons of Mars. Does that guarantee life? No, but it could be. It's a strong indicator. So the probability just went up. And we're now seeing lots of methane coming out of Mars at very unique times to indicate that there very well could be life there. I'm not saying there is, but there could be. And so these are discoveries that need to be had, and NASA is the agency to make it happen. But all those discoveries about liquid water and methane, and just think about complex organic compounds themselves, the building blocks for life, are all over the surface of Mars. Again, does that mean life is there? We don't know, but we need to go find out. The probability is going up. What we do know, because of the rovers that we have had on Mars, we do know that Mars at one time had 2/3 of its northern hemisphere covered in ocean. We know that Mars at one time had a strong magnetosphere to protect it from the radiation of the sun and deep space. We know that Mars used to have a thick atmosphere, just like Earth has. In other words, at one point in the history of Mars, it was habitable. It was livable, if I could say that. Does it mean that there was life there? No, not necessarily. But I'm telling you, what this agency can do is go and find out. And if we do discover life on another world, even a world as close as Mars, or that life was at one time there, I think it's gonna change how we do space exploration. All of a sudden, people are gonna want, what else is out there? We think about Europa, a moon of Jupiter. It's an entire water world. It's the size of our own moon, but the entire thing is water. And it's covered in an ice shell, which means inside there's liquid water. And we're now seeing these massive plumes of water coming out of the ice shell. And that liquid water inside could there be life inside Europa? So I would say, we think about the moon and Mars, definitely the places we need to go first. Then we think about the moons of Jupiter, the moons of Saturn. There are so many just fascinating worlds. We're talking about worlds that are absolutely covered in complex organic compounds. It looks like they're covered in oil, if you will.
This is absolutely amazing. I mean, ladies and gentlemen, you heard it here first. COSI's Digital Science Festival. We're listening to the administrator, Jim Bridenstine, who heads up all of NASA, and he just said, and we all know this, based on the number of planets and the number of sun-like bodies out there with celestial bodies orbiting them, along with the evidence, the data of water they found in different planetary structures that we know in our solar system, you can bet on it. You don't have to be a mathematician to know that the probability is probably likely that there is life out there. With that, I'm going to turn to the life that's been bleeding now on my tweets and my feed. We have a lot of questions for you, Administrator Bridenstine. I'm going to read some. I'm going to try to do them real quick. So what? How has going to the International Space Station different in the time of coronavirus?
I'll tell you, it hasn't been that much different, and I'll tell you why. Because we as an agency have always taken great care to make sure that we don't get any diseases on the International Space Station. I used to be a Navy pilot, and we lived on an aircraft carrier, and I can tell you this: if one person gets sick, everybody gets sick, and it's a bad day. That's why in the Navy they call us swabbies, because we swab the decks all the time. We're always cleaning the ship. And we clean the ship to make sure that people don't get sick, because if they do, it spreads quickly. Well, the International Space Station is even closer quarters than that of an aircraft carrier. So we have to make sure it's clean. So every time we send an astronaut to the International Space Station, we make sure that he or she is quarantined weeks ahead of time. Okay. So they get to health stabilization. Of course, they get immunizations. They are very healthy to begin with. They're selected based on being very healthy. And so we're very careful to let no diseases go to the ISS. And that's as true today as it was before.
That's awesome. Another question here. Let's see. How does NASA and NOAA work together?
That's another great question. So NOAA is the agency that creates all of our weather satellites, or I should say they're the agency that operates our weather satellites. So we think about, how do we predict thunderstorms? How do we monitor hurricanes? All of these kind of weather events. Well, NOAA actually turns to NASA to build those satellites. And so we get the requirements, we get the specifications, and then NASA uses its engineering talent and the private sector to pull those elements together at the behest of NOAA. And when they are complete, we deliver them to space. And then we turn them over operationally to NOAA, who then, of course, within NOAA, you have the National Weather Service, and they provide the weather forecasting that we all depend on.
Wow, that it's great to see government agencies work together in profound ways. So that's fantastic. Another question here is and this is great for all the listeners. What are the best sources to stay current about what's happening at NASA?
Well, I would tell you I'm biased, but I would say the NASA website. We always have news features on the NASA website. I would also say follow the NASA Twitter account at NASA. It's another great place to go. And of course, Facebook. And of course, you can follow me at Jim Bridenstine. So I think those are some really good places to go. And I don't want to start mentioning any private sector publications, because if I do, all of the others will be mad at me.
You got it. We won't put you in that spot. Another great question. What's the most exciting unmanned mission now planned?
Oh my goodness. This
unmanned.
Yeah, unmanned. So this summer, we are launching a rover to Mars, and we named that rover Perseverance. This is one of the mission essential functions that we deemed we needed to move forward on in the midst of the coronavirus pandemic, and here's why. Earth and Mars are on the same side of the sun once every 26 months. So we're both orbiting the sun, but we're in our own orbits. So we align on the same side of the sun once every 26 months. That means if we miss the launch window, we have to take this robot and store it for 26 months. Well, this is a very sophisticated piece of gear. Sure. And if we store it for 6 months, it's going to cost the American taxpayer $500 million. And so we determined that we're going to go down to min crew. We're going to separate our workforce by shifts. We're going to give everybody their personal protective equipment. And of course, if anybody feels uncomfortable, they don't have to continue building this device. But we have been able to move forward. We've kept everybody healthy on the program. And now we're getting ready to launch Mars Perseverance. And I want to tell you, I love that name. Now is a time when we need to persevere. And we have persevered. The thing that I love most about Mars Perseverance, it's going to go to the Mars and it's going to do some amazing things. It's going to cache samples, and the next mission to Mars is going to bring those samples back to Earth for the first time ever, doing a Mars sample return mission. But the thing that I think is most exciting, the thing that just blows my mind, is that attached to Mars Perseverance is going to be another little device that we call Mars Ingenuity. And Mars Ingenuity is a helicopter. We are going to fly for the first time in human history. We're going to fly a helicopter on another world under its own power. And so that's going to be an exciting moment. And it's a demonstrator. Remember earlier we talked about the moons of Jupiter and the moons of Saturn. Well, one of the moons of Saturn is called Titan, and Titan is covered in complex organic compounds. And we need to get a helicopter to Titan. We have another mission right now we're developing called Dragonfly, which think of it as a quadcopter that's going to go to Titan, and it's going to get some amazing knowledge and information about these worlds that are, in fact, moons of these supergiant gas planets.
That's unbelievable. Listen, we got to the close of our time. Administrator Jim Bridenstine, the head of NASA, I want to thank you so much for coming on COSI's Digital Science Festival. Our second year. We're so proud to have you as a partner. I want to thank you. For all the listeners, make sure you check out the at-home science celebration tomorrow, the last day of our science festival. Thank you again so much for bringing your brilliance, your talent, your optimism with how humanity and this great country can move forward in really powerful ways to help all of us be better citizens and better people. So thank you, ladies and gentlemen. You heard it here first. You got the man in real time, Jim Bridenstine. Thank you so much. The final word is yours.
Thank you, Dr. Bertley. Keep inspiring. That's how we're going to move forward. This isn't just for our generation. It's for generations to come. And we need to get young folks ready to go because we've got a lot waiting for them. Thank you.
You got it. You're very welcome. And enjoy your next space flight.
All right. Thank you so much.
All right. Cheers.